Okay, so water with a density of 1,000 kilograms per cubic meter pours from a very large tank. Why it has to be very large, you'll find out in a sec. Of water from a pipe that is 34 meters below the surface of the water. So this is 34 meters. Okay, and what we'll do is we'll make this right at the surface of this liquid. That'll be situation number 1, and this will be situation number 2. Okay, so let's set up our P1 plus rho GH1 plus 1/2 rho V1 squared is equal to pressure 2. By the way, almost all these terms will be nothing, okay? Plus rho GH2 plus 1/2 rho V2 squared. So this velocity here is actually velocity 2, okay? Looks like a 2. That looks like a 2. All right. Now, I'm going to say that the pressure, the atmospheric pressure here and the atmospheric pressure here outside the tank like that is the same. You could just put it in there and then subtract it from both sides or just cross it off now. I'm going to say that the water, since it's a very large tank and this is a very small hole, that this water is not moving at all. Okay, so I'm going to say that V1 is 0. Okay, so now I've got on this side, all I have left is rho GH1. The hydrostatic pressure turns into, and then I'm going to say that this height down here is 0. H2 is 0, right? Because we're at the bottom, right? And so that equals 1/2 rho V2 squared, right? It's like, oh, everything goes away, right? Notice that the density goes away. So more dense fluids will have more pressure at the bottom of them, but then they will require more pressure for the same velocity because of this term, right? Which is everything cancels. So wait. Okay, so we get 2GH1 is equal to V2 squared, right? We can take the square root of that, right? And so it's going to be that velocity 2 is going to be the square root of 2 times 9.81 times the change in height, right? And this is called Torricelli's theorem. Torricelli, how do you spell it? Torricelli. I don't even know. Is it just one L? 2 R's? Torricelli's theorem. All right, let's calculate this. It's called, I'll just say it. I won't try to spell it. 2 times 9.81 times 34. What do we got? 25.8 meters per second. Clips right along. That's almost freeway speed. But 34 meters tall is like a tank. They've got one of these like on Council Crest like that. I think this is what I had in mind when I made this example problem.